Today I am going to cover one of the most versatile and top ranked problem solving methodology called 8 discipline or 8D problem solving methodology. Hi, this is Jagdish Kumar R, Master Black Belt, ASQ certified quality practitioner and lead auditor ISO doing this presentation. 8D problem solving methodology was started by Ford, where they had the challenge of one defect leading to thousands of numbers being affected because of the speed of production. They needed a very effective problem solving methodology and they devised 8D methodology, which is now used as a standard practice in almost all the reputed companies. 8D is usable in a standard corrective action format. That is another great advantage. You need not go for the elaborate 8D template. You can use simple corrective action format. Use this methodology to arrive at a deeper and sustained corrective actions. Another takeaway from 8D problem solving approach is that it supports continuously improve quality through an effective CAPA methodology. CAPA means corrective action and preventive action methodology. 8D methodology drives deeper solutions in CAPA analysis, corrective and preventive action analysis, and thereby the solution becomes more value adding. Now let us know the 8 steps or 8 disciplines. Easy to understand, logically correct and highly value adding, and mandatory requirement for every quality professional also. Also please remember 8D principle can be used in quality problem, no doubt. It can be used in other administrative problems also. The first step here is define the problem. We should take care here to see that we are not defining the problem at a symptom level. We should define the problem at cause level. For example, if the child is having fever, temperature is the symptom. If I try to reduce the temperature as a negative effect, I will not be able to permanently remove the fever. I have to take the child to the doctor. Doctor will diagnose whether it is a viral infection or a bacterial infection. Medication will be given, then only the child can recover. So define the problem at cause level, not at symptom level. Build a team. While building a team, together everyone achieves more. We should remember to build a CFT. What is CFT? Cross-functional team. People from different functional areas who have the knowledge of the problem come together and form a team for a better analysis, better solutions. Third is do containment action. As the problem is analyzed or as the problem is detected, first thing should be done here is damage control. Any number of items available in the shop floor should be immediately withdrawn. They should be subjected to screening, 100% inspection. Good ones should be given for production. Bad ones have to be rectified and given back to production. Please remember, don't stop here. Look at the items in stores. Draw the items, do 100% inspection. If there is a problem, rectify and then only allow the items to be binned in the store. This is the containment or damage control action. Determine the root cause. Root cause is the primary cause for failure. This can be done only through a structured process as follows. First, we have to draw the cause and effect diagram in a team. Then we have to collect the data for failure, draw the Pareto analysis to find out the vital few cause. We can use the SOP also to identify the causes. Then we can use a control chart. If we are actually deploying control chart in our manufacturing area to see where the situation has gone out of control, find the assignable cause like power failure, voltage fluctuation, find a solution and then implement. So root cause should be correctly identified. If the root cause is identified and corrective action is taken on that, the problem will not recur at all. Once you identify the root cause, you should do one more additional step. This is the great value from this particular tool. We have to verify the root cause, whether it is genuine, whether it is correct, whether it is the real root cause or not. Now, if the root cause is correct and the corrective action taken is effective, as you monitor post improvement, there will not be any resurfacing of the problem at all. But if the problems resurface but at a lesser frequency, that means two things. One, the current root cause analysis was not effective, thereby the corrective action was not effective. Number two, there could be one more root cause, independent root cause. This is to be remembered. Many complex problems don't have one root cause, they can have more than one root cause also. This has to be clearly remembered by us. Also, as you do the root cause verification and finalize, you should check in FMEA, failure mode and effects analysis, why this was not entered there as one of the failure modes. If not, make arrangements to enter in FMEA so that FMEA is complete, as well as if this FMEA is copy pasted for a similar item manufactured in future, that becomes a complete transfer of knowledge. Do corrective action. Once the root cause is identified, we can take actions to eliminate the root cause so that the problem does not reoccur at all. This is actually the corrective action. As you take the corrective action, you should not implement straight away. You should do proto-piloting. Implement on 1 number, success. Implement on 5 numbers, success. Implement on 30 numbers, success. Then only do the ramp up to the full scale. And as you do this, also please remember to release at least a temporary instruction sheet asking the personnel to implement this improvement. After monitoring and validating, this particular instruction can become part of our permanent engineering documents. Also, care should be taken to incorporate this corrective action and the knowledge in the revised FMEA. More important here to remember is, as you decide and implement the permanent corrective action, do not forget to remove the earlier fixes, earlier temporary containment actions you have incorporated, like 100% inspection and so on. They have to be removed. Otherwise, they can lead to secondary problems. Next, do prevention. Prevention here means two things. One, do the corrective action, eliminate the problem, see that the problem does not repeat in the product henceforth. Second, use the learning, leverage to hundreds of similar products the company makes so that the benefit is maximized into other hundreds of varieties of products also. 100x benefit is realized. Congratulate the team. This is also very, very important. Congratulate, reward, award. Success breeds success. The motivation the individuals get through recognition will help them to solve bigger problems, further bigger problems, and so on. Thereby the organization gets enormously benefited. Also, the individuals are tremendously benefited in terms of their enhanced confidence and competence. Let us understand the benefits of the 8D principle. One is elevated team performance, collective team wisdom, collective thinking leads to higher solutions. Continual improvement. Continual improvement is directed by 8D principle. In continual improvement, you know where you are. Like my yield is 68% now. You know where you want to go. I want to improve the yield to 85%. In what time span? Say 1 year. This is the characteristic of continual improvement, and continual improvement is well supported by 8D principle. Is a great takeaway. Also, 8D principle is data driven. Because it is data based, it will have enormous accuracy in terms of root cause analysis and corrective and preventive actions being taken. Many times global customers ask what is CAPA. CAPA is corrective action and preventive action. We know now what it is. Here is an example of how 8D principle was used for implementing the corrective action, identifying and implementing the corrective action. This is the corrective action report used by one of the companies. Method used 8D. 8D team was formed. As usual, the customer is mentioned here so that any clarification, it is easy to quickly approach them. Part number affected, what is the description of the part, SS shaft, anode, X-ray, CT 100, what is the corrective action report date, what is the corrective action document number, whether it is external or internal is written here. Yes. Now the defect or fault description is given here. SS shaft diameter is out of spec and more than the upper specification limit of 10.5 mm. This cannot be ignored because the item is critical for the end product. 90 numbers were inspected, 12 numbers got rejected. Now the action is the responsibility of AD team with the leader. In the forefront, for every issue there should be every requirement should have a timeline date. Immediate containment was done, 100% screening of WIP means work in progress items, as well as the lots in the stores were inspected, totally 276 numbers. The inspection responsibility was given to QA supervisor Chidananda with a timeline. Now the root cause was identified and defined. The methodology is followed, cause and effect diagram drawn, all the causes are listed. The causes were analyzed. Here it was found that there was no change in software used for fabrication, no change in machine, no change in operator, no change in tooling. Finally, it boiled down to the material composition or material property. They checked in FMEA. FMEA did not contain any caution on material purity or requirement or actions to ensure purity of materials. The material grade checking was the only option left, which was given to QA material testing in charge, Mrs. Radha. Timeline was given. Permanent corrective action was taken once the material analysis was done. It was revealed, as given here in the description, that the sporadic impurities were found in the material beyond the acceptable limit, and they actually affected the machinability, which led to the dimension being out of tolerance. Now, permanent corrective action taken was to include in the PO term that the supplier along with the consignment should deliver material test report also. This cautioned the supplier, and supplier became more alert. The responsibility to do so was given to materials management in charge, Mr. Sidhu. Then the items were delivered by the supplier in future lots along with the material test certificate. 400 numbers received were fabricated and checked. The problem did not repeat at all when checked in different lots. The improvement was found to be effective, and decision was taken to leverage that knowledge to other 6 varieties of CT shafts made, thereby benefiting sixfold for the company. The documents to be improved were improved, FMEA was modified, control plan was revised, engineering drawing was also revised, and with the improved instruction, the responsibilities were given to materials management and design here. Finally, it was approved for closure by the head medical equipments group. The copies were distributed to quality assurance, materials management, design fabrication department, as well as, please note, quality awards committee to award the team with the appropriate rewards. I take this opportunity to request once again each one of you to subscribe to this channel. Many people view but they do not subscribe. Subscription is free, and the button is given below the video presentation for you to subscribe, so that my future presentations can reach you at the earliest without fail. I take this opportunity to thank each one of you for all the support that you have extended to me.